It was just this past Saturday, February 8th, 2025, that I passed this burning object. An object eternal, but a car no more, because it could no longer transport anyone to any destination. Just the talk of the town going around about the owner's frustration with his lost transportation. But what caused such destruction? Was it electrical, or was it the petrol in its tank that leaked and triggered this ignition that encouraged the manifestation of the blazing inferno, which rendered the vehicle drivable no more, but just an object that sits on the road awaiting its exorcism from that place to the junkyard? Bystanders stood observing, and drivers kept driving by and looking. But can you imagine the person who this sight is frustrating at the moment? It's gone already, but what led to this occurrence? Was it a careless act by a mechanic or a brewing problem which went unseen because of lack of professional vehicle maintenance? Was it a technical flaw on the part of the manufacturer? This car is an older model of Toyota, so it seems that it's no flaw of its maker, so that part is cancelled by this current adjudicator. But one might conclude it was an unnoticed problem due to lack of technical or mechanical observation, when servicing a vehicle is done the right way. I want to take you into the arena of a head adjustment where we see through the shock and after effects and look at the cause and effect of this problem. What caused it? Was it electrical, or was it another issue? Something sparked the flame. It's the same issue that could occur in a jet plane, and we want to delve into this and explain. What a shame that it could not have been prevented. If someone had an extinguisher, perhaps that would have saved the driver from so much pressure now. What causes fires in cars and jet planes, and what could prevent these events from happening? This is the precursor to our search for the answer to this problem, since we do know the causes of it. The question is, can we prevent them? Welcome to our channel. Today we're diving into a critical topic: the major causes of fires in petrol, diesel, hybrid and electric vehicles, as well as jet aircraft. We're going to break down these complex systems, look at the points where things can go wrong, and most importantly, highlight what you can do to minimize these risks, because understanding how these fires start is the first step towards preventing them. Stay tuned to learn how these fires start and what can be done to prevent them. Let's start with the combustion engine, the heart of your petrol or diesel vehicle. A tangle of metal pipes and hoses runs throughout the engine bay. That's your fuel system, under constant pressure. Over time, hoses can crack, wear down, or come loose. Now you've got a leak. A fuel leak is like lighting a match next to gasoline. One spark, one overheated component, and whoosh, fire. Modern vehicles have safety features to mitigate this risk. Fuel lines are reinforced, and many cars have sensors to detect leaks. Regular maintenance is key. Inspecting fuel lines and connections is your first line of defense. Let's talk about overheating engines. Engines convert fuel into power through controlled explosions, generating heat. The cooling system prevents overheating, but if it fails, heat builds up. Temperatures skyrocket, causing potential fires. Let's move on to another potential fire hazard: electrical system failures. Your vehicle's electrical system is a complex web of wires, fuses and components. Electricity and heat go together like fire and fuel. A short circuit, a frayed wire, or a faulty alternator can create a spark, igniting flammable materials under the hood. Electrical fires can be sneaky, smoldering before bursting into flames. They can hide behind the dashboard or inside a wiring harness. Pay attention to warning signs, flickering lights, a burning smell, or strange noises. Don't ignore them. Let's talk about spilled fluids. Not just fuel, but oil, brake fluid, and coolant. These can be flammable. Spilled oil on a hot engine is a fire hazard. Leaks can be dangerous too. Be mindful of leaks. Get puddles checked out. Now, let's talk about a component that's designed to reduce emissions, but can ironically become a fire hazard: the catalytic converter. This little device is tucked away in your exhaust system, working hard to convert harmful pollutants into less harmful substances. But here's the catch: it operates at incredibly high temperatures, sometimes exceeding 1000 degrees Fahrenheit. Now, imagine this. Your catalytic converter is doing its job, burning off those nasty emissions, but it's clogged up with soot and debris. That blockage restricts exhaust flow, causing the converter to overheat even more. And if it gets hot enough, it can ignite nearby flammable materials like dry grass or spilled fuel. All right, let's shift gears and talk about hybrid vehicles. These marvels of engineering combine the power of a traditional combustion engine with the efficiency of an electric motor and battery pack. And while they offer numerous environmental benefits, they also present unique fire risks. One of the biggest concerns with hybrid vehicles is battery issues. These high-voltage batteries are incredibly powerful, but they're also sensitive to damage and extreme temperatures. A crash, a manufacturing defect, even extreme heat, these can all compromise the battery's integrity, potentially leading to a short circuit and a fire. Now, just like their petrol-powered counterparts, hybrid vehicles can also suffer from overheating issues. But in this case, it's not just the engine we need to worry about. The battery pack itself generates heat, especially during charging and discharging cycles. To prevent overheating, hybrid vehicles have sophisticated cooling systems that regulate the battery's temperature. But if these systems fail, maybe due to a coolant leak, a faulty fan, or even extreme ambient temperatures, the battery can overheat. And when a lithium-ion battery overheats, it can experience thermal runaway, a chain reaction that can lead to a fire. And, of course, we can't forget about the electrical system in hybrid vehicles. These systems are even more complex than those in traditional vehicles, with high-voltage components and intricate wiring harnesses. And just like in any electrical system, there's always the risk of a failure. A short circuit, a loose connection, a faulty component. These can all generate heat and sparks, potentially igniting flammable materials. And because hybrid vehicles often carry high-voltage current, the consequences of an electrical fire can be even more severe. Now, one thing that's crucial for both traditional and hybrid vehicles is proper maintenance. Neglecting your car's maintenance can significantly increase the risk of a fire. Think about it. A worn-out serpentine belt can cause your alternator to fail, leading to electrical problems. A dirty air filter can restrict airflow to your engine, causing it to overheat. And a leaky oil pan can create a fire hazard if the oil drips onto a hot exhaust component. All right, let's talk about electric vehicles, the future of transportation. These vehicles are powered solely by electricity, stored in large, high-voltage battery packs, and while they offer numerous advantages over traditional vehicles, they also come with their own set of fire risks. One of the most significant risks associated with electric vehicles is battery thermal runaway. We touched on this earlier with hybrid vehicles, but it's even more critical with EVs because their battery packs are significantly larger. Thermal runaway occurs when a battery cell overheats, triggering a chain reaction that spreads to adjacent cells. This can release flammable gases and create intense heat, leading to a fire that's difficult to extinguish. Now, overcharging is another potential cause of battery fires in electric vehicles. While modern EVs have sophisticated battery management systems that prevent overcharging, malfunctions can occur. If a battery is charged beyond its capacity, it can overheat and potentially catch fire. It's essential to use the correct charging equipment and follow the manufacturer's recommendations for charging your electric vehicle. Avoid using public charging stations that appear damaged or poorly maintained, and if you notice any unusual heat or swelling in your battery pack, stop charging immediately and contact your dealer or a qualified technician. Just like with any vehicle, electrical system failures can also pose a fire risk in electric vehicles. These systems are complex and carry high-voltage current, making them susceptible to shorts, overloads, and other malfunctions. Faulty wiring, loose connections, and damaged components can all generate heat and sparks, potentially igniting flammable materials. It's crucial to have your EV's electrical system inspected regularly by a qualified technician. And if you notice any warning signs such as flickering lights, a burning smell, or unusual noises, address them immediately. Now, while rare, spontaneous combustion is another potential fire risk associated with electric vehicle batteries. This occurs when a battery ignites without any external cause, typically due to internal damage or a manufacturing defect. Spontaneous combustion is difficult to predict or prevent, but there are steps you can take to mitigate the risk. Choose a reputable EV manufacturer with a good track record of battery safety. Park your EV in a well-ventilated area, especially after charging. And if you notice any unusual odors or behavior from your battery pack, contact your dealer or a qualified technician immediately. All right, let's take to the skies and talk about jet aircraft fires. These massive machines rely on powerful jet engines to propel them through the air. And as you can imagine, those engines generate an immense amount of heat. Fuel leaks, oil leaks, and uncontained engine failures can all lead to fires in jet aircraft engines. Modern jet engines are equipped with fire detection and suppression systems, but even these sophisticated systems can be overwhelmed in a catastrophic engine failure. Pilots undergo rigorous training to handle engine fires, and aircraft are designed with fire containment measures to prevent the spread of flames. Now, it's not just the engines that can catch fire on a jet aircraft. Electrical fires are also a significant concern in these complex machines. With miles of wiring, countless electrical components and high-voltage systems, the potential for a short circuit or an electrical malfunction is always present. Short circuits and overheating components can cause electrical fires in jet aircraft. These fires can be challenging to extinguish, especially in flight, as they often occur in confined spaces with limited access. Aircraft manufacturers and maintenance crews go to great lengths to ensure the integrity of electrical systems, and pilots are trained to respond quickly and effectively to electrical fires. Thanks for watching. We hope this video has been informative and helps you understand the major causes of fires in different types of vehicles and jet aircraft. From fuel leaks and electrical issues to battery malfunctions and overheating, we've covered a lot of ground today. Remember, knowledge is power, and understanding these risks is the first step towards preventing them. So be proactive, stay informed, and keep those rides safe. Don't forget to like, subscribe, and hit the bell icon for more insightful content. Stay safe!